Hello everyone. Today we are continuing the lecture previously discussed, the torque speed or torque slip equation. In this lecture we will discuss about the torque slip characteristic, how this characteristic plays important role in the induction machine. Torque slip characteristic is the curve the drawn between torque and slip. It starts from slip 1 to slip to the slip 0, and starting the slip is 1 when n is 0, n is 1. When n is 0, the slip is 1. We all know this thing. When n is 0, slip is 1. And similarly, when n is when n is ns, slip is 0. So these things we know already. Now continuing with the torque equation, the input voltage is E2 and the torque equation is directly proportional to S times E square R2 upon R2 square plus SX2 square. So let us see how this equation uh, helps to study the torque slip characteristic. Basically, the torque slip characteristic is, or torque speed characteristic, we can say both. It is taking this kind of shape where we have divided this curve in three regions. One is stable region, the other region is unstable region, and the point A denoted here is maximum torque showing. So let us start with the stable region. Suppose the equation we previously have considered in a stable region, or we can say that in the where the stable region is showing by OA portion. In this stable region, we can see that the slip is very small, varying from 0 to SM. So if we see that if we put s equal s in comparison to when the value of s is very small, then we can see from this equation that sx2 term can be neglected from r2 term in comparison to r2 term. So the equation of torque will become now as sr2 upon r2 square. As r2 is constant, so we can also say that the torque is directly proportional to the slip, because x2 square is very much small in comparison to r2 square. So sx2 term is neglected. This this sx2 term is coming here. So sx2 square, this term is negligible in comparison to r2 square, so therefore sx2 terms can be neglected, and in the denominator we will having only r2 square term. So torque is directly proportional to sr2 upon r2 square, and therefore we can have the relation torque is directly proportional to slip for the stable region. So now let us see in the curve we have shown here, s is directly proportional to t, therefore it is coming like a linear portion of the torque slip characteristic. Now moving to the unstable region. In the unstable region, the slip is varying from Sm to 1. So we can say that from the torque equation, we can say that Sx2 whole square term is greater than R2 square. So R2 square in the denominator can be neglected, and in the denominator we will having only the Sx2 square term. So cancelling one of the s by denominator and numerator, so we will left with only one single term of s in the denominator. So this is showing that torque is inversely proportional to the slip. So this is showing nothing but a rectangular hyperbola, rectangular hyperbola term. So therefore, the curve is like rectangular hyperbola that is shown by the curve AB. This is the portion AB showing the unstable region. The maximum torque is at the value of S is equal to Sm. So there are three torques basically: starting torque, maximum torque, and full load torque. So we will conclude from here that the motor produces the torque when S is equal to 0, speed is 0. Maximum torque is when S is putting Sm equal to Sm, that is the maximum torque or breakdown torque, and the full load torque is a value less than full load torque, where the motor or where the motor or the machine operates. These are the two torques, TFL and TM. TM TFL is always less than TM. So this is all about this lecture, and I feel that you all got to understand this lecture, and now you can easily explain the torque slip characteristic of the induction machine. Thank you. Take care.